microgrid. This is a new concept we are applying, the virtual inertia control scheme. Okay. So from the fundamental I will start. So first we will see. So this problem is frequency regulation. Means we want to control the frequency. So here we are getting the frequency is at 50 Hz. So first we have to understand what is the importance of this problem. Why frequency should be maintained constant. If it varies, what is the problem? Next we have to understand why frequency varies. What are the reasons? Now after finding the reasons, we will find the remedies. Next, inertia. First, what is the inertia in power system? Conventional power system, they have got some inertia. But renewable energy based systems, they are having less inertia or no inertia. So that thing we will discuss. So how to provide virtual inertia. And then for control, there will be some controllers, and to optimize the control parameters, you have to apply some optimization techniques. So one optimization, you can choose any optimization technique. Arithmetic optimization algorithm we will apply. So to start with, this one. So why the frequency should remain constant? No, first we should understand why it should be maintained. Then we will go for the reasons why it is varying. So frequency should remain constant, particularly in power system, because any deviation from the standard frequency can cause the malfunction of the electrical equipment. The life period will decrease. Okay. So we have studied fundamentals. Say for example, transformer we have studied. Transformer, there are losses, iron losses. Iron losses again hysteresis loss and eddy current loss. So they depend on the B maximum value of flux density, and which is given by V by F ratio. V is the applied voltage. Generally, voltage is maintained constant. So if you change the frequency, that V maximum value will change. So the losses will change. So any loss, if the more loss is occurring, that is obviously it will produce more heat, and our life period of the equipment will decrease. So even less loss also not desirable. No. Like suppose you have got a vehicle, bus, capacity is 50. If 80% sit in that bus, what will happen? So it will damage after some time. The life period of the bus will decrease. Then less is also not desirable. So instead of 50, suppose only 20% they are traveling. So financially we will be at loss. No, you cannot collect the money. So same thing. So for whatever for 50 Hz frequency, all the components are designed. And if the frequency is increased or decreased, so in both ways it is undesirable. So the maintaining a consistent frequency ensures smooth and efficient operation of all connected devices across the system. Okay. So the key points here is the equipment compatibility. Most electrical appliances like motors, they are designed to operate at a specific frequency. In India, we are following 50 Hz. In some other country, 60 Hz. Some other country, 25 Hz. So, depending on that frequency, all the electrical appliances they have been designed. So, deviation from this one will cause the overheating and damage to the components. And when multiple generators are connected to the grid, final student they might be doing this experiment, synchronization. So one condition is frequency should match. So frequency should be maintained, that means. Motor speed controls. So in many applications like industrial machinery, constant frequency is crucial for maintaining the consistency of motor speed. Motor speed, if you say induction motor, majority of motors are induction motor in industry. Almost 70% of motors are induction motor. So what is the speed of induction motor? Speed ns. It depends on the synchronous speed. Synchronous speed is 120 f by p. No. And slip 1 minus s into the synchronous speed is the rotor speed. So rotor speed will be affected if the frequency changes. Then there is one more component is time keeping. So in many industrial applications, we are using synchronous motors to run the clocks, because synchronous motor is a constant speed motor. So clock will run at the constant speed. It will give accurate timing. But that accurate timing depends on the frequency. So to maintain the frequency constant, then only the clocks will show accurate readings. So electrical grid frequency is used for timekeeping, and this timing will be a quantum years. Then the power quality. Power quality generally depends on the voltage quality and frequency. So fluctuation in frequency can lead to voltage variation, and which can impact the quality of power delivered to the customers. Induction motor transformers, they will draw high magnetizing current when frequency drops. So iron losses, as I said, both hysteresis loss and eddy current loss will increase if the frequency drops. That equation also I have used here. The magnetizing current I is proportional to the flux, and flux is proportional to V maximum by A, and V maximum is V by F. So if frequency decreases, the V maximum value will increase. And recall that the hysteresis loss depends on the V maximum. Eddy current loss also depends on the square of the V maximum. No, one is V maximum to power 1.6, and then second one is V maximum square. So from this discussion, we understood that frequency should be maintained constant to increase the life period of all the connected devices to the power systems. Next, we will see why the frequency changes. Why the frequency tends to rise. So frequency is closely related to the real power balance in the overall network. So there are two powers. One is real power, other one is the reactive power. So whatever power you are consuming, that must be generated somewhere. No, automatically you will not get. So consuming means all the loads they consume the power. Plus there will be some losses also. So there should be balance between your generation and consumption. Whatever you are consuming, that must be generated somewhere. If there is perfect power balance, then all the synchronous generators, they run at synchronous speed and they produce the power at rated frequency. So the system generators run synchronously and generate the required power. So during normal operating conditions, the power balance is maintained. So power generation is power consumption, generators are rotating at synchronous speed, then the frequency. The speed and frequency are related. No, F is equal to Pn by 120. No. So number of poles is fixed. So if the speed of rotation is synchronous speed, then we will get the rated frequency. So when we talk about the power consumption may be consumed by the loads plus the losses also. They also consume the powers. And in power system we were talking about the AC system. No, in power system generation, distribution and consumption, majority of it is AC. Only small devices like say mobile or some other devices, they consume the DC powers. So AC power cannot be stored efficiently. DC using battery you can store. AC is a costly effect. No, you could transfer, change again from AC to DC. In the form of DC you can store, but in the form of AC you cannot store. So AC energy is transported at almost velocity of light, and it is not being stored continuously. Continuously it is not stored. In some rotating parts, in the form of kinetic energy, some energy is stored, but unlike DC power, you cannot store the AC powers. So all the rotating parts, they possess the kinetic energy. So AC means because you are not storing, so whatever electrical energy production rate must be equal to the consumption rate at each instant of time. There should be balance. No? Whatever generation is equal to our consumption. So who is consuming? We are the consumers. No? So consumers as and when required, they will switch on the load. No, now the seminar started here. So we put all the lights. So to combine the collective loads of all the consumers. So loads will suddenly increase or decrease. So accordingly you will change the generation to match with the load demand. So if this balance is disturbed, then what happens? So user of electrical power, we are the user of electrical power. They change the loads randomly and momentarily. Okay. So as and when required, we will change the loads. No, we will not see that whether generation is there or not. So then what will happen? If the load demand is suddenly increased, so obviously that power balance will be disturbed. No. Earlier case, suppose there is a complete power balance. So 10 megawatt suppose consumption means you are generating 10 megawatt. Suddenly you have connected a load. So by that time you will not increase the generation. So what will happen? How you are getting the energy there? So that is the theory here. So when the power balance is disturbed, at the instant when you suddenly load the system, then the generation is less than the power consumption. No. So originally you take some figure like say 10 megawatt generation, 10 megawatt consumption. Suddenly 1 megawatt load you have connected. So now the consumption is 11, generation is 10. So how that is possible? Because how we are consuming more than the generation. So there what will happen? The generator output. You to increase the generation obviously. To maintain the balance, again you to increase the generation. How to increase the generation? In power plant, you allow more mechanical energy to run the turbines. No, steam means you will give the more steam input. Hydro turbine means allow the water to those things. So the generator output, they are controlled by mechanical devices. So mechanical input power to the generator should be increased to make this increased load. But mechanical systems is slow and takes time to respond. So immediately you cannot increase the input. But electrical quantity, any electrical quantity, suddenly we can change. So to switch on the load, we will get the power. But mechanical power, suddenly you cannot change. It will take some time. They are slow to respond. So then what happens? Initially the energy is drawn from the rotating mass. That is the kinetic energy of the rotor to meet this increased load demand. So when suddenly a load is connected, the energy will be drawn from the rotor. No, any rotating part which possesses some kinetic energy. So from there, the energy will be drawn. And when you draw the energy, the rotor speed will decrease. And hence the frequency will decrease. It is like suppose you are moving in a bicycle at a particular speed. If one of your friend comes and sits in the bicycle, what will happen to the speed? Momentarily there will be decrease in speed. So same thing will happen here. Rotor speed will decrease and hence the frequency will decrease. So this rate of speed, the speed and frequency are related. Speed, no. F is equal to P n by over 20. Speed is directly proportional to frequency. Or frequency is directly proportional to the speed. So when speed decreases, frequency also decreases. So what will happen? If suddenly a load is connected to the power system, the frequency will decrease. How much it will decrease? It will depend on what is that magnitude of load. How much load you have connected. If you have connected a small load, the magnitude of decrease may be less. From 50 to say 49.95 Hz it may come. If you connect a large load, it may 49.5 Hz. So it will depend on the amount magnitude of the load. What is the magnitude of load you have connected. So here one important concept is that energy is drawn from the rotor.